Okay. Good morning, everyone. How did your homework go?
So it went well.
What? It went well, great. So we're developing the idea of a series, which remember, a series is basically the way we write it is it's just a sum of numbers. You keep adding them and adding them. But the question was yesterday, what does it mean to add infinitely many terms? What really this means? The idea is that the meaning is the following: we associate to every series the sequence of partial sums. That's really the idea. So we add the first n term, and we look at the partial sums. If those partial sums exist, means if those converge to something, then we say that the sigma is basically the limit of those partial sums. That's really the definition. And intuitively, what this means, that a series converge if we add sufficiently many terms, we keep adding terms and getting terms and adding terms, those sums become close to a number. That's really the idea. Okay, Chris, have two questions. So we do them because they elaborate this idea and then we proceed. So number 57. Which 67. 67. All right, so they give us the following series: summation I equal 1 to infinity of 2 over the quantity 2k minus 1 and 2k plus 1. And the question is basically to find the partial sum, find S1, S2, S3, S4, see a certain pattern coming up, and then find Sn. So basically they want me to find a formula for the sum of the first n terms, and then see what happens when n goes to infinity. So we do that, we compute S1. So first let me go back to the series itself and start writing the terms up. So sorry, this should be k. I don't know why I wrote I. Okay, so it's 2 over, if k is 1, I will have 2 times 2 plus 1. So basically I'm going to have a 3 here, plus 2 over, if k is equal to 2. So it's like the odd numbers, every other odd numbers or consecutive odd numbers. So if k is equal to 2, I will have 2 times 2, 4 minus 1. I will have 3 times 5 plus 2 over, so if you add, so this is k equal to 1, k equal to 2, k equal to 3. We're going to have 5 times 7. Okay, all the numbers are odd, and then the pattern continue, 2 over. If I put k equal to 4, I'm going to have 7 times 9 plus etc. We keep adding them. And the idea is that what does this mean? So we're going to compute the partial sums. So the first term is F3. And then I'm going to compute the sum of the first two terms. And the idea, we keep doing it in those particular problems till we find a pattern occurring. 3 times 5, so common denominator is going to give me a 10. 10 plus 2, so this is 10. Plus 2 over 3 times 5. So that's give me 12 over basically 3 times 5. And now divide by 2 both, so it's going to give me a 5, and this is going to give me 4 over 5. So that's for the first term. I guess the pattern is occurring. Now, the sum of the first 3 terms. All right, what's the sum of the first 3 terms? It is 2 over 3 plus, so we're adding, plus 2 over 5 times 7 equal. I've already added, that's the sum of the first, plus 2 over 5 times 7. And now common denominator of 5 times 7. I'll have to multiply this by 7. That'll give me 28. 28 plus 2, that's going to give me a 30 over 35. We simplify by 5. This will give me 6 over 7. So I will compute one more, and then you guys tell me, okay, is a pattern occurring? Now, those are simple problems. We can see the pattern. Most of the problem, this is really impossible to be able to do. But to understand the concepts we need simple problem. So 5 times 7, then I need 2 over 7 times 9. Again, I've already taken care of that. This is the 6 over 7. And then I'm going to add 2 times 7 over 9. And this would give me 9 times 6, 54, 56 over 7 times 9. And then 56 into 7, that's in 8 over 9. All right, so there is obvious pattern occurring. So now watch the pattern. What is the sum of the first n terms? That's really what I want. And you guys, of course, it's very clear. 4, 9, 3, 7. So that's basically the 2n plus 1, as you guys wrote correctly. And this is 4, 8, 3, 6, 2, 4. So basically, this is 2n over 2n plus 1. It means if I add the first, yeah, exact. So it's 2n over 2n plus 1. So if n equal to 4, it's 8 over 9. N equal to 3, 6 over 7. N equal to 2, 4 over 5. So that's really the sum of the first n term. It means if I add the first n term, so I keep adding, plus, 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 up to the nth term, which is to n minus 1 to n plus 1, I get that much. So I've added the first 100, I get 100, 200 over 201. The first 1,000, 2,000 over 2001. So if I keep adding those terms, that's really what I get. So that's the formula for Sn. So now what's the sum itself? So what is this whole sum equal to? So what's this sum? The sum is nothing more than the limit as n tends to infinity of the partial sum. It's actually what happened to those sum when n goes to infinity. That's really what the total sum is. So it means we need the limit as n tends to infinity of 2n over 2n plus 1. Now when n becomes very large, 2n over 2n plus 1 will actually become very close to 1. And the answer is equal to 1 in this scenario. Okay, so that's really the idea of what does it mean to sum. We keep adding terms, ask ourselves, what are we getting close to? And that's really what we mean by the sigma notation. Now imagine number 68 is actually verbatim the same. I don't think it's anything different. 68 is like I did in class yesterday. Go over what I did in class yesterday. I took exactly the same sum, verbatim the same sum. So you can look it over. Right. Another question beside those two. Okay, so today we are going to start the first type of series that you're going to study a little bit in detail, and this is called the geometric series. Okay, so it's section 10.3. These are, believe me, will be basically the important series, and they will be, unfortunately, the only series that you will understand fully. After that, it's going to become a little bit harder. So what's a geometric series? A specific type of series. So a geometric series is a series of the following form. It's a very specific type of series. So geometric series is the series of the following form. So how the terms of the series are. Series of the form like this. You have the first term, whatever it is, plus. The second term is the first multiplied by a certain number r, plus. The third term is obtained from this multiplied by r. So I multiply the second term by r. So it's a r squared. And the third term, the fourth term here, is a r cubed, and so on and so forth. So it's a geometric series. It's a series where every term is obtained from the one before it, multiplied by a constant r. So from here to here, from here to here, we multiply by r. From here to here, we're going to multiply it by r, multiply it by r, and so on and so forth. That's a very specific type of series. Now, in sigma notation, how shall I write this in sigma notation? How do you want me to write this? Go ahead. Who wants to write this series using sigma notation? Either speak up or put it on the chat.
You could just do AR to the whatever your constant is, so like K. And start with
exactly.
0.
And is it K start with 0 all the way to infinity? So that's what a geometric series, that's how it's, if we retype the term, that's how it looks like. In sigma notation, it's a constant a times r to the k equals 0 to infinity. Whatever you want to call your index, as your classmate said, you can call it k, r, n, I don't care, but a, r to the k equals 0 to infinity. R is called the ratio. R is called the common ratio. Okay, we call R, we give it a name, and we call the common ratio, and A is just the first term. Those series comes up a lot, and they play an important role in our class. So let's see some examples to see them in with numbers instead of only constants. So example, typical example is, suppose I give you the following, 5 plus, so very straightforward example, 2/3 plus 5 2/3 square. That's really how it looks like. Every term is the term before it times a constant. The term before it times a constant. So that's a very simple plus, so on and so forth. So that's the sigma 5 2/3 to the power k equals 0 to infinity. Okay, so the ratio here is 2/3, and the first term is 5 right there. Not every time the series will be written in such a easy way. Suppose I have something like that. Okay. Is this geometric series? Yes, no. If yes, what's the ratio? And then we're going to write it in sigma notation. Is this geometric?
Yes.
Yes. What's the ratio in this case?
1/3.
Okay. What are we multiplying by every time? From here to here, what are we multiplying by?
-1/3.
-1/3. What are we multiplying by from here to here?
-1/3 again.
-1/3. So what's the ratio in this problem? The ratio is the number we multiply by. In this case, the ratio is -1/3. Okay, so we have to be very careful. So here what we're multiplying by is -1/3, not +1/3. So the ratio here is going to be equal to -1/3. Now, who would like to write this clearly in sigma notation? So that's a geometric series. Every time multiplied by
Could you
minus.
do
Go ahead. Go ahead.
1 over negative 3k?
1 over -3. And how do you want the k? Like
As
this?
like an exponent. Can you put it
Like-
all in parentheses though? The -3. Just
All right.
just
I'm trying to see what you want me. Is this what you want?
so it's just 1 over -3 in parentheses. Just the -3 in parentheses.
And where do you want me to put the k?
In the denominator. And then you put the k to the -3 in parentheses in the denominator.
Oh, okay. So I'll write it down here. So what your classmate is saying is 1 over -3 to the power k, right? Is this what you're telling me?
I think either would be okay.
Yeah.
Okay, right. K equals 0 to infinity. Will it be the same thing as this way? Are those two exactly the same? K equals 0 to infinity. Are those two ways of writing the same? What do you think? It's important to see that.
No, because the k would go to the 1, and then 1 squared would not be, or 1 cubed. Oh yeah, it would be the same.
Those are verbatim the same.
Yeah.
Those are exactly the same, because 1 over minus 1 over 3 to the power k, if you want, you can look at it as 1 over -3, correct? The whole thing to the power k, if you want to look at it this way. But this is 1 to the k over -3 to the k, which is basically what you wrote. Okay, that's another way. Who can find a third way to write it? Because I want you to start seeing the stuff in different way. I want you to be able to interact with sums. So that's one way to write it in sigma notation. That's another way to write it in sigma notation. How else can we write it in sigma notation?
Can we do it the same way we did the other time, like -1 to the k times?
Exactly,
1
and exactly, and I want you also to see that. So another way we can write this is the following: -1 to the k, and that's what we did before, because we said over 3 to the k, k equal 0 to infinity. Okay, so we can write this in several format. This is exactly, this way of writing should reflect the original definition of geometric sum. So -1 to the 3k. This is telling you that -1/3 is the ratio. So that's one way we can write it. Or another way you can write it is -1 to the k over 3 to the k. So I want you to be able to see all those, because I wanted to recognize in this a geometric series, in this one a geometric series as well. All right. So now the big question is, when do those series converge? So the big question is, when do geometric series converge? It means when we add terms that look like the one we were talking about, we get close to a finite number. So when do geometric series converge? And what's their sum? And what is the sum in case they converge? Now, the idea is that to find whether they converge or not, we have to look at the sequence of partial sums. So we start with a geometric series, A plus A times R plus A times R squared plus A times R cubed, and so on and so forth. So my ratio is R. And in sigma notation, it's A, RK, or R, whatever you want to use for the constant, I don't really care. All right, I use K because your book is using K. Now, to find when they converge, I need to find Sn. It means if I add the first n term, what do I get? So let us see. What is Sn? First, let me compute S1. S1 is A. S2, And this time pattern is not gonna come up, so we have to do a little bit of manipulation. So S3 is A plus A times R plus A times R squared. So Sn is A plus AR. So Sn is the sum of the first n terms. Okay, so the first 3 terms I get up to R squared. So this will take me A times R to the n minus 1. Okay, the reason is n minus 1 because from A R to the 0, from 0 to n minus 1, I have n terms. That's why it's Rn minus 1. And the question is, what's a formula for Sn? It means what's this sum equal to? Okay, before I give you the formula, I'm going a little bit to tell you where the formula is coming from, and then we will proceed. So it's a bit of a tricky way of, so my goal now is find a formula for Sn so I can compute the limit. So we use the following trick. This is Sn. I'm going to multiply Sn by A. So this is a trick to find a formula. Multiply Sn by A. So my goal is to find a nice formula for the sum of the first n term. That's really my goal. So that's how we're going to prove it. We multiply across by A, we get A times Sn equal. Multiply by A, every term. Sorry, not A, I meant multiply by R. I will get A times R plus A R squared plus A R cubed plus etc. A, multiply this by R, this is gonna give me Rn. Okay. And now we're gonna take the following. So as I said, it is a trick to compute, give a formula for Sn. Now I'm gonna take the difference. I'm gonna take Sn minus R Sn. And let's see what do we get. So I'm gonna take the difference between those two. What do I get? A plus AR squared, blah, 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 minus this. This would leave me with what? Anybody? Means I'm gonna take this term, subtract this whole thing. My goal is to find a nice formula for Sn. Okay, I will get A plus minus, cancel each other out, plus minus, cancel each other out, plus minus, cancel each other out.
Would it be times R and to the negative to the minus 1?
It's gonna be A
Minus, right? A to
minus
the R to the end.
A to the Rn. We're gonna come up with that. Watch what's happening. I'm subtracting them. A, that is not subtractive. AR minus AR, cancel each other out. R squared, cancel each other out. R cubed, will cancel each other out. And then I will have ARN minus 1 is going to cancel out with the term that comes before that, because the term that comes before Rn is going to be Rn minus 1. This one, there is nothing that's going to be canceled from, so I will get ARN. As I said, it's a nice trick. It's a very good trick. Now I'm going to factor out Sn, get 1 minus R equal A minus A to the Rn.
I have a question.
I'm listening.
How did you like scratch off the A times R and minus 1?
I'm taking Sn minus R Sn. I'm taking the difference. So let me take it actually like this. Suppose I'm going to add a line. Okay, I'm adding a line to make it clearer. 1 minus that. So this is A. This is A times R squared, plus etc. ARN minus 1. And this is AR squared, plus etc. plus the last term is ARN. Now if I subtract them, what will I get? A here. I have AR from this sum. I have AR from this one. That's how I'm scratching. Then I have AR squared here. minus AR squared. They scratch each other out. And then I keep going, scratch each other out. Now ARN minus 1, the term before ARN should be A R to the n minus 1. This is also going to be scratched out. So I'll be left with A minus ARN.
Oh, okay, that makes sense.
All right?
Yeah, okay.
Now I factor out my Sn. So as I said, it's a trick. I mean, it's some, to prove something, we need ideas. I will get A minus R. So now I will have this Sn is A minus A R to the n over 1 minus R. So the sum of the first n terms is going to be given by the following formula. A minus ARN over A minus R. Okay, so before we proceed and say what's going to happen, so for example, okay, suppose I'm going to add the following, just to see how this formula, suppose I look at the following series, sigma k equal 0 all the way to infinity of 1 over 2 to the n. Okay, let's take 2 to the k, sorry. So this is a 1 plus 1 over 2 squared plus 1 over 2 to the power 3 plus etc. 1 over 2 to the k plus so on. Okay, and let me compute the sum of the first, 10 terms. So 1. So I'm going to compute as 10. As 10 is the sum of the first n terms. 2 to the power 3 plus etc. And because I'm starting at 1 over 2 to the 0, and I want the sum of the first n terms, this would be 1 over 2 to the 9. And what this formula tells me, it's equal to. It's equal to A. In this case, my A is 1. It's going to be 1 minus. R is a half to the power 10 divided by 1 over minus a half. That's really how we're applying this formula. So 1 minus a half, it's a 2. So I'm going to have 2 times 1 minus a half to the power 10. Okay. Is this going to be a small or a large number? What do you think as 10 is going to be close to? Is a half to the power 10 going to be small or large? Back to you now.
Small.
Small. That's a number less than 1. When we're going to take it to a large and large value, this is going to be really a very small number. Even if you take 1 over 2 to the power 10, you're going to be very small. So if I take s to the power 100, what we're going to have, so if I keep applying this formula and I evaluate larger term, I add the first 100 terms, I'm going to have 1 minus 1 over 2 to the power 100 over that. So will the series converge in this case? Do you think this series will converge? Let me write what I'm saying. Suppose I compute the first 100 terms for the same series. The formula tells me you're going to get the first term minus a half to the power 100 over 1 minus a half. It means 2 times 1 minus that to the power 100. Now, is this a small or a large number?
Small.
Small. So what do you think Sn in this particular example is going to be getting close to?
2.
It's going to become close to 2. And 2 in this case is going to be the sum. So sigma of this sum is going to be actually equal to 2. Okay? So that's the application to that. So this series will converge and will converge to 2. Now we're going to see the theory in general. What's happening in general? So let's see what in general. So let's go back to the general case.
I have a question now. Could you show what you got for the second one again? Right there. Thank you.
Okay, let's go back to general case. So we have this A plus a times r plus a r squared plus etc. And that's my geometric series. And the sum of the first n terms is equal to a minus a r to the n over 1 minus r. So that's really the general situation. Now, if what my goal is, what happens when n goes to infinity? When n becomes very large, what's happening to those partial sum? What do they get close to? Okay, before I write the result, I'm going to ask you the question. What happens when n becomes very large? Those partial sums are going to get close to what?
Are we assuming that r is less than 1?
That's the whole idea. That's going to depend on r. So what's going to happen? It will depend on r. If r is less than 1, when n goes to infinity, this will go to 0 and the series will converge. If r in absolute value is bigger than 1, the series will diverge because those terms don't go to 0. Those terms diverge. So the sum of the geometric series is going to depend on this ratio. If the ratio is less than 1, it will converge. If the ratio is bigger than 1, it's going to diverge. So now let us sum this up. So if r in absolute value is less than 1, then the limit of r to the n, that's what we saw, is equal to 0. That's what we saw last time. If you have a number less than 1, you raise it to a higher power, the number is going to go to 0. So the limit in this case, as n tends to infinity of the partial sums, is going to be the limit as n tends to infinity of a minus arn over 1 minus r. But this would goes to 0. So the limit is going to be a times 1 over 1 minus r. And in this case, the series converges. And the sum of the series, the sum, will be a times 1 over 1 minus r. Okay. So if the ratio is less than 1, the series will converge because the partial sums will converge. It converges to that number, a over 1 minus 1. If the ratio is bigger or equal to 1, and that's what, if the ratio is strictly bigger than 1, then the sequence Rn diverges. So those don't get close to anything. They either blow up to infinity or the limit doesn't exist. So as n, the partial sums, the limit does not exist if you want, or diverge. So the series will diverge. Because the series is exactly what happened to the partial sums. Okay, so that's really what happened for the geometric series. So this is a geometric series. We understand it very well because we can evaluate the partial sums. And then now the suggestion was, if the r is less than 0 in absolute value, then Rn will go to 0, the series will diverge. When r is bigger than 1, if this r is bigger than 1, then we know that the Rn goes to infinity. It means the sum will go to infinity. If r is less than minus 1, the Rn just don't converge, as n will not converge. So I will write this in a big box, and then we will definitely start practicing this. So now we have the following. So we have the following for a geometric series. So we summarize. If r, the ratio, less than 1, the geometric series sigma A R K, K equals 0 to infinity, converges. It means that as we add more term, we get close to something. And not only converge, and we know the sums become close to what? And sigma A R K, it means A plus A times R plus A R squared plus so on is equal to, means when we add more terms, equal to A times 1 over 1 minus R. But what's A? I want you to memorize A. Okay, A is the first term. I would like you to memorize it this way, times 1 over 1 minus the ratio. It means that's the sum. So converge, and the sum is the first term times 1 over 1 minus the ratio. If R, the ratio, is bigger or equal to 1, the series diverges. It means it does not get close to any fixed number, or it blows up to infinity. Okay, Wyatt, your classmates asked me if you need to memorize the formula for the partial sum. No. For the partial sums, no. But this one, yes. This one, absolutely, yes, you should know. Okay, because I need it. And of course, you're going to be tested on it tomorrow, and we need the sums. Okay, now let us put it to practice. So we're going to do several examples. Okay, example number 1. Okay, the first very straightforward example. So suppose the question is, for each of the following geometric series, decide if the series converge or diverge. In case it converge, find its sum. That's really what the question is. So suppose I give you 1 over 2 to the k equal 1 to infinity. Now, is this a geometric series? What do you think?
Yes.
Yes. If you are in doubt, which is sometimes you are, you have to write up the first few terms. And I strongly encourage you to always write the first few terms of a series, because it helps us to understand what's really going on. It helps me see the terms. Okay, that's that. Right? Now, what's the ratio here? So from one term to another, I'm multiplying by a half. So that's really, so the ratio here is equal to a half. Okay, so the ratio is less than 1. It means that the series converges. So we have to go through every step. Ratio less than 1, the series converge. So now what is the sum? It means if we start adding those terms, it's basically, if you actually honestly pick up your calculator, start adding more and more terms. What's this sum is going to be close to? Now let's see what this formula tells me. It tells me that sigma k equal 1 to infinity of 1 over 2 to the k is equal to the first term times 1 over 1 minus the ratio. Now what's my first term here? My first term is my first term. My first term is a half. That's what my first term in this scenario. You just say, what is your first term? You multiply this by 1 over 1 minus a half. And then you do the simple math. 1 over that, 1 over 1 minus a half. So it's times 2. It means this sum is equal to 1. Okay? So it means if you add those terms, it's equal to 1. Now, probably some of you have seen, there are several pictures that really kind of reflect this. I will show you one simple picture. Suppose you have a line here, okay? And you move half a unit. Imagine yourself, you move half a unit along this line. And then you move, so you're right here. You move half of what you moved before. So you moved a half, and then you move half what you moved before. It means you move 1/4 square. You're right here. And then you keep moving half of what you moved before. So half of what, so every time you multiply by a half. So you move a half, then you move half of what you did before. So 1/4. Then you move half of that. That's 1/2 to the power 3. An imaginary scenario. Then you move half of what you moved before. And you start adding the distance. Then you move half. You keep doing this for infinity. The most, you cannot go beyond 1 unit. So you start here, you move a half. Then you move half of what you did. It means you add that. Then you move half of what you did. You add that. Then you move half of what you did. You add that. You keep doing this to infinity. You will never go beyond 1 unit. Okay, so it's a very non-intuitive ideas, but very important ideas. All right, so now let's take more examples. Example number 2, and this time I will slightly make them a little bit harder, not much. So example number 2 is the following. Sigma, I'm going to take the following. I'm going to write it in sigma notation. -2 to the n plus 1. To the k plus 1 over 3 to the k, and k equal 1 to infinity. Question now 1, is this a geometric series? And if it is, what's the ratio and what's the sum? All right. So an easy way to find out its geometric series, my advice to you is write up the first few terms. When you write up the first few terms, you can understand the series much better. What's the first 2 terms here? So the first term is -2 to the power 2 over 3. Then for k equal to 2, basically I'm going to have -2 to the power 3 over 3 squared. And then I will have -2 to the power 4 over 3 cubed, plus so on and so forth. So basically I'm going to have, because 2 squared over 3. This is -2 cubed over 3 squared, plus 2 to the power 4 over 3 to the power 3, and so on and so forth. So question number 1, is this geometric? What's the ratio?
I have a question. I have a question real quick.
Yes, I'm listening.
Why did you put a subtraction sign over just the first one and not the second one, or is it just implied that they're all being subtracted?
If I take k equal to 1, I have -2 squared, right?
Yes.
-2 squared is the same thing as 2 squared. Because minus squared is a positive.
Oh, okay.
-2 to the power 3, that's -2 to the power 3, that's negative 2 to the 3. Positive 2 to the 4. Are you getting it?
Okay. Oh, yeah. Okay.
Minus squared, positive.
It's just because they're positive.
Yes, minus to the power 3, that's going to give me negative, positive, and so on and so forth.
Oh, okay.
What's the ratio here? Are we multiplying by a constant ratio?
Two over 3.
Is it 2 over 3?
Negative.
Wait,
2.
no, negative 2 over 3.
Negative. You have to be very careful. Negative 2 over 3. Negative 2 over 3. Okay, so my ratio here is minus 2 over 3. So now my ratio is less than 1 in absolute value. The series converges. That's step number 1. Step number 2, what's the sum? To be able to find the sum, I need the first term. The first term is the first term. That's what the first term is. So my first term here is 2 squared over 3. And now we apply the formula. So sigma, so if I start adding those quantities, k equal 1 to infinity, I know that we get somewhere, and the ratio is going to be 2 squared over 3. That's the sum. That's the first term, times 1 over 1 minus the ratio. Be careful, the ratio is negative. And now we do the math. That's going to give me 4/3 times 1 over 1 minus minus plus 2/3. And now common denominator, and we finalize. 1 plus 2/3, that's going to give me 5/3, which is 3/5. And that would give me 4/5. End of the problem. Okay, so we have to recognize the geometric. We have to find the ratio very carefully. And then after we do that, we apply the formula. Okay. So let me give you another example where the ratio seems a little bit hard now. Right? Suppose I give you something like this. I'm telling you it's geometric because very soon we won't have geometric. 1/5 to the power 2k. K equal, let's see, I want to start from 1 to infinity. So that's my sum. I want you to find the ratio in this sum. And my advice to you, write the first few terms, then you can see the pattern much better. Find the ratio, and then tell me, does the series converge or not? I give you a minute to do that. When you find the ratio, you write it up for me.
Sorry, what was the answer for the previous problem?
Unless I goofed, I got 4/5.
Okay, thank you.
Okay. Are you following the math though?
Yes.
Yeah. All right. I want the second one. I want you to tell me what the ratio is in this problem. Write up the first few terms. Anybody, what did you guys find?
1/5 squared. That's what I got.
1/5 squared, exactly. So let us write it down. So it's 1/5 if k is 1 to the power 2 plus 1/5 if k is 2 to the power 4. 1/5 if k is 3 to the power 6, and so on and so forth. That's really how it's moving. So what is the ratio? It means what am I multiplying from one term to another? From 1/5 to the power 2 to 4, I'm multiplying by 1/5 to the power 2. I'm multiplying by 1/5 to the power 2, and so on and so forth. So here the ratio is 1/5 squared or 1/25. Okay, so my ratio is less than 1 in absolute value. It means the series converges. And what does it converge to? It means if we start adding those terms physically, what do we get? So the sum is going to be equal to the first term, whatever the first term is, times 1/1 minus 1/25. And then we do the math. So we're going to give you 1/25 times 25/24, which will give me 1/24. So if we add those numbers, we get 1/24. Now, before we finish, I want to ask you the following questions. Okay. Here's my question. The same series. how to recognize geometric series if it's written as a sum. If once we write up the term, recognizing it is easy. You say, okay, what's the ratio we're multiplying by? If we don't find one, it means it's not. If we don't find a common ratio, it means it's not geometric. Now, if it's written as a sum like this, how can we immediately recognize it? A geometric series should have the form A times R to the K. K can start at 1 or infinity, it doesn't really matter. But it should be R to the K. So in my series here, 1/5 to the power 2K, K equal 1 to infinity. How can I write it so that it will have this form, R to the K? So how can I rewrite it so I can see that it has exactly this form? Can anybody see it? I don't know if you guys understand it, what I want. Means how can you rewrite it so it will have this form? A times that.
Can you bring the square into the 1/5? Like,
We can bring the square to the 1/5. So it's going to become like that. Am I right? So I can write it 1/5 squared to the power K, the whole thing to the power K. Once you write it like this will become my R. This constant number is really going to become the R. So sometimes it will be written in a hidden way. When it's written as a sum, it will not be written very clearly A times R to the K for you can see the R, but we can manipulate, we can perform some algebra to make it look exactly R to the K. So in this case, I can write it, A is 1, so I don't really need the A, not I don't need it in this particular scenario, that's a 1, and 1 to infinity, and this is going to become 1/25 if you want, the whole thing to the power K, and my R is actually 1/25. But when you apply the formula, you have to be very careful. The sum is 1/1 minus R, but the term here is the first term. It means to be able to find this one, you have to find out what's the first term of the series. So whatever you start with, like you started at 1, the first term is 1/25. If you start at 2, the first term is going to be 1/25 to the power 2, and so on and so forth. So that's the first type of series we learn. We're going to become almost the only one who will understand fully. It means we understand the actual value of the sum. Starting basically after the spring break, we will be doing is just develop technique to decide whether the series converge or not. We will not have the luxury of finding the actual value of the sum. We will see that later. Okay, so as usual, tomorrow is your quiz and we'll cover everything we've done, including today. So it will cover sequences, limits of sequences. It will cover the meaning of the series as limit of partial sums, as well as geometric series. Okay. So class is dismissed. Anybody with questions can remain.